Listed in the data table are amounts of strontium-90 in a simple random sample of baby teeth obtained from residents in 2 cities. Assume the 2 samples are independent simple random samples selected from a normally distributed population. Do not assume the population standard deviations are equal. Completes parts A and B. Okay, so we first need to determine the hypothesis, null and alternative hypothesis. So it says use a 0.05 significance level to test the claim the mean amount from city 1 is greater than the mean amount from city 2. Okay, so we know that the null is always equal, so that leaves B and C, and it just says that mean 1 is greater than mean 2, so it's got to be C. Okay, what is the test statistic? Now we're going to use technology. We've been doing that the whole time, and I'm only going to get you started on this, okay? So we have a data table, so we're going to click on the data table, and we have city 1, city 2. So again, there are 2 different ways, primary ways they can give you the data. They can give you the summary statistics, which we've seen earlier, where they go ahead and give you the N, the sample mean, sample standard deviation of both. Or they can give you the raw data. Now in practice, when you're actually doing your own research, you're not given summary data. You collect the data, and you actually have to compute the summary data. So we're going to do that. So we have city 1, city 2. My StatLab makes this really nice, where we can click this button here, and we can open it in StatCrunch. Now, isn't that nice? I don't have to type all that in. Now, if you're using TI-83 you've got to type in it. It's not that big a deal. It's about 22 values or so you got to put in. But imagine if you had 100 or 200 or 1,000 in here. You would not want to use the TI-83. So we're going to go to Stat. We're comparing the sample means, so we're going to a T-Stat. We always use T-Stat for sample means. We always use proportion stats for proportions. We generally will not use Z-Stat. So T-Stat, we have 2 samples. This time we have with data. So choose with data. And we're going to do 1 in sample 1 and 2 in sample 2. It does say that the standard deviations are not equal. We can't assume that anyway, so we're going to unclick pool variances. I wish they would make that by default, let you opt in. And we want that mu1 is greater than mu2. Now, if you want to go ahead and crunch out summary statistics, you can. If you want to go ahead and do dot plots or histograms, you can do that, QQ plots, etc. They went ahead and told us that we can assume it came from normal population, so we don't need to do that. Okay, and here we are given the T statistic and the p-value. Now, I'll be honest, I was hoping they would go ahead and give me the summary statistics. I've got to be able to see those. It just gives me a better intuition for what I'm doing. So we have summary statistics. Let's go ahead and include summary statistics. Okay. Because now I can look at the means and see, you know, city 1 has a mean of 150, city 2 has a mean of 115. So it really appears that city 1's, at least in that small sample that we had, that its sample mean was indeed greater. The question is, how likely is that happen by chance, given that they are equal? And we have our test statistic, and we have our p-value. And I'm going to let you proceed from here. Okay, if you're going to use the TI-83 we have 24 values to put in, so not that big a deal. You press Stat, select Edit, and I already put the data in, so you don't have to watch me painfully type all those in. You just type the data in. Okay? It is so easy to make a mistake when plugging these in, so really be careful if you're using the TI-83. And now we're going to press Stat. We're doing a test. Doing a 2-sample t-test, which is the 4th one down. And this time we're not using stats, we are using data. We have list 1 is L1, list 2 is L2. The frequency of list 1 is 1, frequency of list 2 is 2, and we have mu1 is greater than mu2. We are not pooling, and we press calculate. Okay, just notice we have the same values here. The test statistic at 1.5509, 1.5509, p-value at 0.0705, and p-value 0.0705. So we get exactly the same values. And I mean, I guess one nice thing about TI is it automatically gives you the summary statistics. We can compare the mean 150, 115. So while indeed it is larger, it's not statistically significant, right? So we would fail to reject HO. And we might want a bigger sample if we're pretty convinced that it is larger, we can do a bigger sample on the study. So I hope that helps.